Hello again, everybody. We are continuing our talk about rotational motion, and we are going to talk about now if an object is in rotational motion like this one. So the object is here at a certain time, so I'm gonna call this here T1, and the object was found here at a certain time T2, and this is the radius, and this is the radius. Now this is the angle. I'm gonna call this angle here theta 1, and for this one I'm gonna call this big one here theta 2. Okay, remember now the difference between the two angles, theta 2 minus theta 1, is what we talked about before, which is the angular separation or angular displacement. Okay, so we are actually talking about rotational motion. We're not going to talk about position, we're going to talk about angular position. We're not going to talk about velocity, we're going to talk about angular velocity, and here is the angular acceleration. And I made this title on purpose so that you can actually try to relate. Everything is the same, but we're talking about circular motion now. Okay, so remember when we had the object coming, that's kind of like x1 and that's kind of like x2. We found the displacement here, we called it x2 minus x1. Then we found the velocity, if that was t2 and this was t1, we said the velocity is x2 minus x1 divided by t2 by dt1. We can actually find here, so we found the position, that's theta 1 and theta 2, and theta 2 minus theta 1 is the angular displacement. Okay, so we talked about that before. Now let's talk about the velocity. Velocity for the angular position, instead of v, I'm going to call it w. W in French like W. So this is actually read as omega. So this is omega. So you can say omega is equal to position number 2, which is theta 2 minus theta 1 divided by t2 minus t1. So this is called the angular velocity. Okay, notice that theta 2 is bigger than theta 1 and the object is going this way, right? So this motion here like that is known as counterclockwise. Okay, the object is going counterclockwise and theta 2 is bigger than theta 1. Of course, time number 2 is always bigger than time number 1. If theta 2 is bigger than theta 1, this is counterclockwise. And just to talk about sign, the sign that would be always positive. Okay, just like when you are going to the right in the x-axis, that's always what? Positive. So you're going counterclockwise is the same as you're going to the positive direction in the x-axis for linear motion. Okay, now what is the unit of omega? It's actually the unit of theta divided by the unit of time. Remember, the unit of theta is not an angle, actually, it's rad, it's an indication, and the unit of time is second. So this is rad per second, or some people just say simply 1/2. That's actually possible. Now, where did we see 1/2 before? That's actually for the hertz, that's a frequency. However, this omega is not the frequency. This omega is known as the angular frequency. And the angular frequency is equal to the frequency, that's it, multiplied by the angular part, which is 2 pi. So that's omega. That's another equation for the angular frequency, and we called it also angular velocity. Okay, just to give you like a taste of how things could be integrated with each other. All right, good. Now we are going also to define something else. We are going to call it angular acceleration. So I'm going to put it that here in this narrow angle. Angular acceleration. And instead of writing it as A for angular acceleration, we write it as alpha. So alpha is the angular acceleration, and if I might just write it here, that would be better. Okay, that's alpha. And if the object here has an angular velocity omega 1 and it changed its velocity at position 2 at t2 equals to omega 2, then alpha is the change in the angular velocity, which is omega 2 minus omega 1 divided by t2 minus t1. Okay, and also, so that's the angular acceleration, also positive for counterclockwise. Okay, that's it. What's the unit? If you look at the unit of alpha is equal to the unit of omega divided by the unit of time. The unit of omega is rad per second, and the unit per time is second. So that's rad per second square, or just per second square if you don't want to put rad. Okay, so that's it for these two equations, these two important equations, this one here, and this one, and of course this one. That's a very good equation. Theta 2 minus theta 1 is the angular separation or angular displacement, so that's also important equation. So we're almost halfway through the chapter, believe it or not. Okay, let's have a few examples within the next video, and we will call it a day. All right, thank you.